pretty. ES6 is much more popular, and then there's these other not as popular things. So it's a really interesting way to go and look at trends in the industry. And obviously this is a little skewed or biased, right? Not everyone is going to answer this survey. It might be more focused on certain types of people. So that's definitely true. There's a demographics part here where you can go and read about certain areas. It says US dominated, but Germany and Australia are well represented. So I recommend going and viewing this. They have the previous years here too, so you can see trends over time. It's really interesting to go and read about. And then another resource here is the Front-End Developer Handbook, which one of the sponsors she mentioned earlier, Front-End Masters, they publish this handbook every year, and it kind of tells you a summary of what happened the previous year in front-end development, and then tries to predict what might happen, right? Because they don't really know. But they have a good idea. And so here you can see all the things that happened in 2018. A lot of these I didn't even know about, so it's kind of good to go and read about what happened in the industry. And then they have a prediction section here, and you can go and look at that. So interestingly, they have web components down here, which is kind of what I'm going to talk about today. And they say they really don't know how it's going to play out, so that's kind of my feeling too. But it's interesting. It seems to go in waves. Either it's really popular, and then it's kind of fades away to darkness, and then it's really popular again. So
real popular after your talk.
exactly. This talk's going to set it on the map. Yeah. So let's go back over here. So how does this change impact developers and the companies that they work for? So for developers, I kind of think of it as 3 phases. The first phase is you start to get stale skills. Maybe I'm on a company for 5 years and they're using Knockout.js or something. And I start being an expert in that, but no one is really going to hire me in the future for that. So your skills start to become stale, which maybe you're fine with, maybe not. If you're not fine with it, you go into stage 2, which is your job satisfaction starts to go down. Maybe you start getting upset that you're not working on the latest frameworks. Maybe you think you could make more money if you knew those frameworks. And then the third phase is ultimately you end up leaving the job for a new technology because your company maybe can't absorb the need for you to expand your skill set. But from the company side, it's also not everything's perfect there. They have a limited developer interchangeability. So say they have 10 developers and they have 3 projects, and they want all of these developers to work on all the projects so they can just move them around based on demand. Well, they can't do that if every project they have, if all 3 of those projects is using a different framework. Developers are flexible, right? They can go and learn a new framework. It's not a big deal. But they're going to be much more efficient if everyone is on the same page and they can share ideas. It's much harder to just learn framework after framework and try to reapply those best practices, because the best practices always are different for every framework. And then oftentimes companies cannot justify rewriting an application. So I mentioned that our company has rewritten an application a few times, but the way we justified it was drastic feature changes or a user experience implementation that's different. But if you're just rewriting the application just to have a new framework, you're going to have an application that's working perfectly the way it is in an old framework, and then you're going to rewrite it exactly as it is in the new framework, but it's going to be worse because you're going to have all these bugs that you didn't have in the old one because you don't remember what those bug fixes were, right? That's years of development. So companies can't justify that. And then it's also really hard to attract talent with old technologies. So how many people go and look at jobs and see things for Knockout or older JavaScript technologies? There's not much out there. Sure, maybe they'll pay a lot because they can't find anyone to do it, but it's really difficult for companies to hire like that. So both sides of this equation have a say or a desire to try to fix this problem. And so what I'm going to talk about today is one possible solution to this problem. And I'm going to bring this back up. So what is the constant in this equation here? And I kind of already mentioned it earlier. It's vanilla JavaScript, right? No matter where I was across all 14 years, I was always doing JavaScript in some form. And when it's added to the spec, it's never removed. Or if it is removed, it's deprecated over a long period of time. It's highly unlikely anything you wrote 10 years ago is not going to work today. So that's really important. And so maybe there's something in JavaScript and just vanilla JavaScript where we can try to help, stop some of these massive changes. And there is. It's not that new, but it's web components. And browsers are starting to adopt this more and more. So that's why I consider it new. I guess it's newly adopted in most of the web browsers. So just a quick show of hands, who has heard of web components before? Okay, so most people. Who has used one in production, though? Okay, so like 2 or 3. So that's the problem with web components. It gets all this attention, and then really no one ends up using it. But it does partially solve this problem. And so just to define and talk about what web components are, they're really not just one thing. They're a set of specifications that browsers can implement. And that set creates a new custom reusable encapsulated HTML tag that you can use on the web and web apps. And so these are the components that a web app or web component have inside of them. And when you think of web component, you're likely thinking of the first one, which is custom element. The custom element is really the HTML tag that wraps all of your functionality inside of it. And so on the right side here, I'll always have a code example of how you implement this specification. So what you have to do first is you create a class, custom elements global function, or global object. You call define, and you pass it the name of the tag that you want to give it. So in this case, it's my element. And then you pass it the class that you're implementing. So there, now anytime I use my element, it's going to use that class. And the shadow DOM, which several of you have probably also heard of this because it's been a popular terminology, it encapsulates parts of the DOM or styles into a certain part of your page, and they can't bleed out and impact other portions of the page. So that's incredibly useful. And this is sort of the obscure way to add it to your application if you're using vanilla JavaScript. You use this attach shadow, and you pass in a mode, and I honestly forget what the different modes are, but you can go and look that up. The default standard is generally open from what I've seen. And one thing I forgot to mention as I'm going through these, think of your favorite JavaScript framework, so Angular, React, Vue, it doesn't matter. Think of that in terms of these 4 specifications. And these are very, very, very similar to those frameworks. So think about that as we go through this. And third, ES modules, which I think is probably not that important in a web component, and especially because only Chrome supports this. All the other browsers don't. And it's the ability to import a file, a JavaScript file, into a different file, or import a piece of function. So here we're saying import some func from my element. And so that's a way to do the imports. You're likely used to this in your frameworks, but it's because it's transpiling that code into something the browser understands. You're never executing this natively on your browser because nothing supports it except Chrome. And then last, there's HTML template, which again, I think is probably lower on the list of specification, interesting pieces. But it's a tag called template that you can put on your page, and then nothing between those tags is ever rendered until you inject it into something. Okay, we talked briefly about browser support. Firefox and Chrome support most of these. Firefox doesn't support the import. Safari has partial or limited support on some of them. They don't allow you to extend an existing element, and they have some issues with imports and that kind of thing. And then Edge and IE don't support anything. No surprise, but there are polyfills for all these things, so you can go and add extra code to your bundle, but it'll fix this problem for you. And just one note, for those of you not aware, Edge is going to be Chrome-based in the future, so that is probably a separate set of concerns and topics, but it's good because, in one way, because we're not going to have to support an older spec anymore. And if you go quick to can I use, if people have used that website before, if you search web components, it lists all 4 of these specifications and gives you a ranking of how many browsers support this. So templates really well supported, not well supported imports, shadow DOM, and custom elements are pretty well supported. Then at the end, you kind of see an overall ranking for a web component. So really, it's a set of things, which actually I didn't know when I started this presentation. So I think it's maybe I don't know, maybe I was alone, but felt like it was one spec. So let's look at a demo quick of a web component before we get into exporting. So I'll post these again later, but there's this landing page I made where you can go through all of the notes and demos that I'll show. And so this first one is this vanilla web component demo. And if you click on that, there's a demo here of a basic web component. So I like football, and I always default to football for my, my demos, that or something with my kids. And I like the Packers, so the Packers are going to win a lot this year, and the Vikings are going to lose. And you'll notice this isn't even really purple, it's kind of pink. So, just throwing a little shade at the Vikings. But all of these there's a web component put 4 places on this page. So it's, a reusable component. And then you'll see inside of that, there's different things. So a Packers text, a cheese, a Vikings logo, a horned emoji. So these things are all passed into the web component as attributes. And just real briefly, we'll talk about how that works. So in order to import this web component, we just source it as a normal script. Can everyone see that okay in the back? Yeah, okay. Bump it up maybe. Is it the contrast or the size? Okay. So we source that file, and then here we have a messages section, which has this blue section here. It always has what our last action was. And then we each have a div for each team. And you'll see here there's a win-loss counter, and that's our web component. So that's a HTML tag there that's different than we were used to seeing. And you can see I pass in a team name of Packers and a color, and that defaults the color. And then I have some information inside of it, which is the logo. And so then if you look at the contents of the web component, I'm not using templates the way I just described earlier. I'm just kind of hard coding a template inside of this. So I guess it's not officially a web component, but it uses several of the features. So here's the HTML that is going to be injected inside of every one of these web components. And it's using an ID, which you'd think maybe would cause a problem because there'd be duplicate IDs on the page. But it doesn't. It's not a problem because we're going to use a shadow DOM. And so everything is inside of that shadow DOM, and there's no duplicate IDs. And so here is sort of the bulk of this code. And again, think about the JavaScript frameworks you're used to using. So we have a win-loss counter, extends HTML element, and then there's an observed attributes. And what this is a list of attributes that we want to pay attention to if they changed. So if color changes, it's going to notify me, and then I can adjust various things on the page. And then connected callback gets, I have comments above each one here, gets called when you get inserted into the DOM. So this would be like an Angular ng on init, or whatever the React version is and Vue version. That's how that works. And so here on the insert, I'm getting that template, I'm inserting it into the DOM. I'm creating a shadow root or a shadow DOM element, and then attaching everything inside of that. And then here I am initializing the content based on the attributes that are passed in. So I'm using the shadow DOM, and I'm getting the element by ID. So this is within my own element, my own template. It's getting this information, setting the inner text, and then using the attribute that was passed in to me. So it's a little bit more verbose than you're used to seeing in like a React or a Vue component. But essentially, it's accomplishing the same exact thing. And so then I also have to hook up the win and loss buttons. So I do that here. I just said add event listeners for the click. Then there's a destroy callback. If you need to clean stuff up, you can do that. If you care about if something's moved, you can hook into that lifecycle event. And then this is what gets called when something in that observed attributes changes. So in my case, I was looking at color. Well, if color changes, I want to change the color of the background. So I get the root, I can find the container, and then I change the background to the new value. Again, it's very similar to what you could do in a framework. And then finally, frameworks usually have the concept of like an output or an event that you can fire out of a component. And that's what this is doing here. When I click win or loss, it's going to dispatch an event, which is a function that's on the HTML element. And then I'm going to pass in a custom event with a name of record change, and it's going to pass in the information that the display section needs to display it. So everything that you would expect in a normal framework component is being done here. And then at the end, I'm doing that syntax that we talked about earlier to define it as a win-loss counter. And all of that happens in these sections here. So it's just reused over and over again. Okay, and then the way you'd listen to that normally is, I'm going to speed through some of the rest of this example because I want to get to the meat of this. But you'd add an event listener, look for the record change, and then update the messages dialog or the message section. And then just to briefly show the lifecycle hooks at the bottom here, let me try to bump that up. There's the console, which I can't get any bigger than that. But it says custom element created, so there's 4 of those. So as soon as I loaded the page, 4 of those lifecycle hooks got triggered. And if I want to get rid of the bears, I just click remove, and they're no longer the Packers problem, and they're over here, and now I can see that it was calling that console log in the disconnected callback. So then I want to change the colors. We can just change it to real purple, and we'll go back to the console, and you can see that I got a console log, which was triggered in the attribute changed callback. So all of that works as expected. Okay, so like I said, really similar to JavaScript frameworks, reusable components, HTML tag-based. There's inputs and outputs. There's lifecycle hooks. You can style encapsulate. It sounds very, very familiar, right? Well, if they're so familiar, maybe there's something we can do to utilize it in our current framework applications. Maybe there's some way we can make this rapid change a little bit more stable. And that's when I started looking at the export to web component. And I first got interested in this because the Angular team, I guess most of our applications at work are Angular based, and the Angular team introduced Angular elements. And so what I did is I went and read about that and got really excited, and then found out there's a bunch of caveats and it's not quite ready. But I spent a lot of time investigating Angular elements, but then wondered, well, what do the other frameworks do? And so that's what kind of got me looking into this path. And so what I'm going to show here is information about how you would go about doing this. First, there are packages available to do this for all of the major frameworks, so Vue, Angular, React. It probably also exists for stuff like Svelte or some of the other up-and-coming frameworks. But what it does is it wraps your framework component in another component that it creates, and it communicates between your framework component and the browser so that both understand each other. It's like a translator, essentially. And it does this all with relatively minimal overhead, but you also still have to import the framework to do this, because it's not taking your framework code and automatically making it vanilla. It's just communicating the difference. And there's a great difference in maturity between these wrappers, which I'll get into. But here's just a pictorial view, which I don't need to go too in detail with, but you use the wrapper, you put in the framework component, and then what I'm going to show eventually here is an application that has 3 different wrappers with 3 different framework components, and each framework component is a different framework. So eventually we'll show an example here that has 3 of them, and it's going to load an Angular, a React, and a Vue component all in the same app wrapped with web components. And remember, like I said, you have to import a minimal runtime. And so off here on the side is the runtime that you have to import in order for this to work. So this is sort of a pictorial architecture view of what it would look like. So why would you ever want to do this? There are actually some pretty interesting use cases for this, and some of them tie into the problem that I was talking to earlier. It could be an upgrade path for a newer framework. So if you're stuck on the older version of Angular, AngularJS, and you want to go to the newer version of Angular or React even, you could use this and selectively take pieces of your application and rewrite it in the new framework, export it to web component, and replace it in your old application without really being that disruptive. I mean, you'll have to load more bundle size and that kind of thing, but no one would really know any difference behind the scenes. You could also keep investment in old code. So maybe you have a cash cow application and no one wants to touch it because it's making so much money, and you want new features on it, but you don't want to use that old code. Well, you can add new code on top of it using this method. And then you could embed framework components in stuff like a content management system or a server-side rendering that normally can't have dynamically injectable things, you could inject this script, theoretically, if it allows you to, and then just use it as a normal HTML element on your page, and then you'll suddenly render Angular code inside of your CMS. And then in theory, you could use it for a component library. Component libraries you find are typically written for a specific framework. Well, maybe you could write it in one framework, author it in Vue, and then export it to web component, and then every framework could just use the web components. So you kind of save yourself some rewriting there. So now I'll go a little bit into detail about each one of these. I'm not going to spend a lot of time on each one because every time I talk about one, I'm alienating like 2/3 of you because some of you maybe are not Angular developers. But just out of curiosity, who does a lot of Angular here? Okay, very few. Okay, what about Vue? Okay, still very few. And I assume everyone else is React, I guess? Okay. Interesting. So, I'll kind of speed through the Angular and the Vue parts, but just give you a little bit of details on how they compare. So Angular, it's an officially supported package, like I mentioned earlier, but using it outside of Angular is not really officially supported yet. They say it's coming because, and the reason they don't support it is because the bundle size is too large. They're not minifying it in a way that's practical for you to use in another application. So if you search this, there's tons of blog posts about how to use this outside of Angular, but none of them are really sanctioned. And what I'm going to show is definitely not sanctioned. It's Wild West, but yeah. And you'll have to roll your own build for doing this. But like I said, there's improvements coming. So React, I'll spend a little bit more time on this since we kind of have that audience. There's no official package. React is really interesting because there's not a lot of community support or interest in doing this with React. And I kind of feel like it's that way because React is so popular and no one really cares, if you're going to convert React to something else because everyone's using React anyway. So I'm guessing that might be why, but they do have a page on their documentation about React and how it works with web components. There's nothing stopping you from using React and web components. It's just they don't officially support this path. There are third-party packages, which I ended up using. I probably spent the longest time on this talk trying to figure out how to do this with React because there are so many packages, and a lot of them are just total garbage. And you'll see they have very similar names, which is even more confusing. So my favorite is React Components, but don't confuse that with React Web Components because they're very different. And there's another one just called, I think, Web React Component with no S. So you really have to kind of look on NPM and see, okay, what am I actually getting? I ended up downloading some sample from some company that had nothing to do with anything. So be very careful what you're downloading. But again, with React, there's no official process, so you have to roll your own build, which is less of a problem with React, but it's still a thing to consider. So Vue, I'm not going to talk a lot about Vue, not because we don't have developers here for Vue, but because they do this phenomenally. You have very minimal effort to do in order to export to web components with Vue. I sat down and thinking it would take 3 days, like it took everything else to do this. In 5 minutes, I had something exported to Vue, and they even gave me an HTML page showing me that I could do it. So Vue is really on board with this. So we'll go into a demo of how to do this. So like I said, some of this is pretty complex, and on the GitHub page that I will post, there's a README. So in the O2 export examples, there's directories here for Angular, React, and Vue. And if you click into those, there's a README for each one that describes really what I was trying to accomplish here, because I'm not going to be able to go into details on every single one of these steps, because really each one of these is probably a separate talk. So I'm just going to be very high level on how to do this. But if you want details, talk to me after, or go and read this, and you can kind of recreate my steps. And so each one of these has a README there. But this is what we're going to create. So remember I talked about that application where I'm going to kind of mix everything together. Actually, you know what? I forgot to show the original. So this is the original. Let me show that first. So I wrote the same application 3 different ways in all 3 frameworks so that I could export them into web components. I colored them based on the color of the framework, and then went through the process to export all of the components from these into something that's generic. So there's 3 components on each of these. There's the title bar, which is a component, the add grocery text field, which is a component, and then the grocery list, which is a component. And so I wrote it 3 ways. All the code, even the data layer is exactly the same between both, and I tried to make everything kind of equal. And I think someone earlier was talking about how to compare frameworks. Doing like a basic app like this is really interesting. You find out a lot about the framework. But that's not what we're here to talk about. So let me go into the export examples. So again, we didn't have a lot of Angular users, but I'm going to pull up Angular first since it starts with A. So just in summary, what you have to do with Angular is you add Angular elements, which adds some other things into your bundle too, like document register element. And then to get around a build problem I ran into with doing this, I also had to add ngx build plus. And I won't really go into too many details on why that is. There's a README that explains it. But basically, if you try to do a Webpack build of Angular and a Webpack build of React and slam them in the same web page, they start overriding each other with their variables. And I was getting stack traces that was saying React was calling Angular and Angular was calling React. And it was just like this big nightmare. And it took me days to figure out what was happening. Well, it turns out there's a bug that's, I think, on Create React App and the Angular CLI that they're kind of using a default. And so they end up using the same default. And they kind of step on top of each other. And so this build plus helps me work around that a little bit. And so with Angular, the key with an Angular app is the app.module. That's where you start the application. Generally, there's a bootstrap component in here that tells Angular where to start. But I took that out because I don't want to bootstrap an app. I want to actually export an element. And so instead, I'm overriding that bootstrap and I'm doing nothing. I'm saying don't bootstrap the app. And then I'm importing this create custom element, which comes from Angular elements. You send it the component that you want, you give it the Angular dependency injector, and then you call custom elements.define, which is vanilla JavaScript. And that's it. Everything should work, assuming you bundle it properly, which is a big assume because it's not easy because they don't support this officially. And then one last thing with Angular, because we're trying to be true to the web component spec, Angular has view encapsulation turned on by emulated by default. And so you can turn on Shadow DOM here. So now I'm saying use the native Shadow DOM. So just a very minor change. So now let's talk about React. And I'll spend a little bit longer on React here. So like I said, I imported web React components, not all of the other incantations of this that I talked about. There's a lot of activity on it recently, so I think it's by a few people maybe. There's, I think, 3 or 4 contributors. It had a few hundred downloads on NPM per week. So it's not incredibly popular, so there's some risk there if you decide to adopt it. But it really worked really, really well with our React code. One thing that I mentioned, so I mentioned that there was Webpack config problems between Angular and React. What I ended up doing was changing the build to use Parcel. So has anyone used Parcel here before? So if you haven't looked at Parcel, you should maybe take a look. It's really, really nice. It's a way to bundle where you just say, I want to bundle this file, and then it looks at all the imports and everything it uses and just puts it all in one directory for you without any config at all. And when I saw that, it was really nice because all I had to do was say parcel build, and then I give it a JavaScript file, and then I give it an output directory, and it just goes and does everything magically. So that's what I'm using here instead of Webpack. Create React App uses Webpack, and so I just kind of set that aside. I use that to create this project, but I'm not building with it. So we've imported, or we have the npm install there. Then let's look at the title component. Some of what I'm going to show here is probably shortcuts. There's probably better ways to do this with bundling. I was using a GitHub PNG file here. I had some trouble getting it to bundle properly. You could probably do some Webpack config or parcel config to get it to bundle into the bundle. But for purposes of simplicity, what I did is I just base16 forward encoded the image and just stuck it in line. So I had less moving parts here. Similar with the CSS, for those of you that, I guess everyone here does React, so maybe everyone already knows this, but when you do an import of styles in React, it's actually importing it globally on your entire app. So just because it's importing in this component doesn't mean it's restricted, which is actually a problem when you try to export to web component, because there's a shadow DOM in web component. And shadow DOMs ignore global styles. They only care about the styles in their segment of the DOM. And so none of these styles were getting applied. So one way to do this would be use a bundler to try to get the actual contents of this file and then put it in line in your component. But it started getting too complex for the purposes of what I'm trying to do. I'm just inlining the CSS now here. And then down here in the actual element, I am putting a style tag with the actual styles that I pull in and inline it inside of the shadow DOM. So if you were to go and follow my instructions, that's what you would do. If you were going to do this for real life, you'd probably want to figure out how to do that with bundling instead. So it's kind of a caveat there. But otherwise, nothing else changes here. All the props are the same. I didn't change any of the code. And then at the bottom, I'm importing registers. So if I go back up, I import register from web React components. I pass my component into register. I give it the tag I want to use. So all my tags for this exported example are the framework dash title or whatever that is. And then this third argument is an array of attributes or props that you want this wrapper to pay attention to. So it's very similar to that observed attributes section that you remember from the generic web component. It's just saying I want to keep track of that text. If that text ever changes, I want you to make sure that you re-render and set state and all that React stuff. And then to make it a little bit more complex, we have components that have events. Remember, if I go back to the grocery list and I click on, I guess I never clicked on one. If I click a grocery, it's going to cross it off. I need to know, the app needs to know when something happens inside of that list. And so the way to handle that, and I guess let me take a step back. Web components, when you pass in an attribute, you cannot pass a complex object. It's a string. So I can't pass a JavaScript object or a function into a web component. Those are what web component properties are. So it's a little bit different of a concept. But all the frameworks, allow you to pass in all kinds of whatever you want into the inputs or props, right? You can pass arrays, objects, whatever you want. And so the way that this wrapper is handling it, my prop item clicked was actually a function I was passing in. Well, now it's asking you, this fourth parameter is saying any events that come in that are tied to item clicked, instead of doing what you normally do, trigger a new custom event called item clicked and pass in the information. So it's a way of sort of proxying the event, and custom event, like I showed in the vanilla example, is how you would do let me scroll up so people can see, is how you would do a event in a just standard DOM way. It's not Angular specific, not Vue specific, it's just generic DOM. And so this syntax is confusing. Their README kind of talks about how to do it. But that's basically it with React. Again, not too many changes, but there are some things you have to consider that sort of add to the complexity of this moving part thing. So I'll move on to Vue. Vue, like I said, requires almost no effort to do this. So there's a extension of the CLI. The CLI serves global you have to install. And then it's literally a command that you run. So I'm going to say, run a build that's targeting web component. I give it a prefix. So all my tags will start with Vue, WC. And then I give it the list of Vue files. And then it just goes and does everything. And then, like I said, I had to change no code. And then it creates this dist here. And there's even an HTML file that has the components inside of it. So if I pulled this up, everything will just render like I was using it on a normal HTML page, because that's what it is. So Vue is really good support for this. It's really fantastic. Okay, so now I briefly showed this. This is what I want to do, right? So I just talked about how I exported all of these. It's got a bunch of bundles and everything. Now I want to pull it all into one page. And so I'm going to create this monster, which is Angular, Vue, and React all in the same thing. I like to call it my forcing the kids to play together thing, because my kids don't play well together sometimes. So sometimes you have to kind of force them, or do something to get them to play together. Well, that's basically what you have to do here. Is you have to force the exports to play nice together. So I said there's that Webpack problem. You kind of have to know about that ahead of time and then figure out how to resolve it. But there's a 0.3 using exported components. So there's two directories in here. There's a React-based app, which is a create React app that uses Angular and Vue components inside of it. And then there's a vanilla-based one. And so I'm going to show the vanilla-based example, which is a regular HTML page with a very minimal amount of JavaScript. And so what you have to do first is you have to import all of the stuff we just built. So I'm sourcing the Vue files, and like I said earlier, you have to import the framework too. So I'm importing the minimized Vue, and then I'm importing the minimized exported components. And then I ran parcel on my React components, so I have a single file that has React and my exported components in it. And then this is the part why Angular doesn't officially support using it outside of Angular, is it has a ton of dependencies because they don't have a way currently to sort of take only the pieces you need and put them in this bundle. Angular is expecting you to use it in an Angular app, so it requires all the Angular stuff. And so if you were going to actually do this in a real life example, you would probably take all these requirements, these dependencies, put them in a single file, minimize them, and probably tree shake stuff out. For the purposes of the demo, that just got way too complicated again. I'm just importing all of them. And then this last file is a I think it's minimized version of the bundle that I exported. Then there's a data service, which is just a way to house the grocery list that I'm accumulating here. And then we go right into the app here. So there's a main content section. I decided to use Angular for the title. Then I have a scrollable area with a Vue add grocery, and then a React grocery list. So you can see I'm passing in just a normal attribute for the text, and that was an input in Angular terminology, and the Angular elements just maps that without any problems. And then I added these IDs here because the add grocery and the grocery list don't take any inputs, but they accept, well, I guess the grocery list takes the input of the items, but these two items emit events. And so I have IDs here because I want to know when those events are emitted. And so what I do here is and there's obviously different ways you can attach event listeners to the DOM. So I use this way where you get the element by the ID, you add the event listener. And so anytime the grocery added event comes from the Vue wrap component, I'll update it, and then I'm updating the items property inside of the React component. So remember, grocery list is the React component here. And items, if you remember, if we pull back up grocery lists, we were telling this React component that items is going to change, and when it changes, pay attention to it. Okay? And then similar with the item clicked inside the grocery list. When that's clicked, I want to toggle it, and then I want to make sure that I update the grocery list items with the new set of groceries. So that entire app that we wrote in those other frameworks is boiled down to just this section of code, which is pretty small, but under the scenes, it's doing all kinds of extra garbage that it doesn't need to do. So we'll end up with this example. It's got the three frameworks on here. Everything works as expected. But then if we inspect this page, you can actually verify that it's actually different frameworks involved here. So anyone familiar with Angular knows this ng syntax. Angular adds ng to various places in your DOM to kind of track things. So you'll see the Angular title added ng to various places. And then there's a shadow root, which is inside of that web component. So it's got encapsulated styles in there. And then I'll move down to the Vue component. And people familiar with Vue know that it adds v dash something to various elements, similar to Angular. So you can see it's really a Vue component in here. I didn't just fake it. It's really Vue inside there. And there's a shadow root in there too. So that's great. And then React, the thing with React is you can't really inspect the DOM and easily tell if it's React, at least as far as I know, unless you inject some other stuff in here. So this is React. It's got a shadow root, and then it's got its, remember we inline those CSS files, so it's inlined here. So it's proof. You can marry all these things together. You know, should you create an app with 3 different frameworks? No, but you know, if you can, you know, that's cool. And I guess I didn't realize, but this is blue. I guess it doesn't look very blue here, but it just represents that it was React. Okay, so let's go back to the presentation here. So limitations, I'll kind of breeze through these since I already talked about some of them. There's no export path, must handle own build, a lot of prereqs at the moment, you know, but they're going to improve that in the future. For those of you not familiar with Angular, they just spent a lot of time redoing their renderers with something called Ivy. So it's supposed to make Angular a lot faster and lighter. So that was taking all their attention. And then, like I said, the Webpack output does not play well with React. And that's not Angular's fault, and that's not React's fault. It's just they both did the same exact thing the same way. Limitations of React, there's no official package, which in my opinion is probably a pretty big risk. So like I said, the one I picked is like 200 downloads a week on NPM. If you decide to use that and, you know, in a production app and, you know, in a money-making app, and suddenly that package goes away or they stop maintaining it, you have to make sure that you're okay with the responsibility of forking it and maintaining it yourself. So it's a pretty big risk to not have it as an officially maintained thing. Again, must handle own build, not very popular in the community. You don't find a lot of people trying to do this with React. And then React and custom elements actually have a number of compatibility problems. So there's a website called Custom Elements Everywhere, and they run a set of tests, basic tests and advanced tests against all the various frameworks, or a lot of them, and it'll give you a score. So AngularJS, Angular, all these frameworks I've never heard of, super old frameworks like Dojo, and then if you scroll down, you get to React, and React fails the advanced tests. And there's examples of or issues that document those failures, and it's not that the React team doesn't care because they are addressing these. I think they just want to do it in the most efficient way that's practical for everyone. So there are concerns. If you want to do this, you should go read these issues and understand what the limitations are. And I didn't show Vue, but Vue is also 100% in here somewhere, Vue 100%. Okay, so Vue, it struggled to put one here. It requires the runtime, but so does Angular and React. So honestly, there's no limitations that are not obvious. I mean, there's limitations for web components in general that I talked about. You can't send objects, that kind of thing. But that's not Vue's fault. That's in the spec. So really the question is, you saw this, should I go and use it? And the answer is maybe, because I don't really know your scenario. But really what you should consider is the business need, right? Am I doing this just because it's cool and it's something new I want to do at work? Or is there actually a practical reason that this is useful? So I mentioned some use cases earlier, you know, an upgrade path, that's a business need, right? If you're trying to upgrade to something newer and the business wants you to, maybe you can justify this wrapper. But are you doing this in a way that's going to be hard to maintain or increase complexity? Those are other things to consider. And then finally, if you're going to do it as like an upgrade path, make sure you have a path to completion, because there's nothing worse than an old framework, except for an old framework that has half of a new framework embedded inside of it and no one knows what's going on. Yeah, that's much worse. So make sure if you know, you're the one guy doing it at your company, you tell the other person, you know, what you're doing so that you don't leave them stranded. I talked a lot about bundle size. Bundle size is a big thing to keep in mind here. And then last, you should really consider vanilla JavaScript. Is there a reason you even need a framework at all? And with that, the alternatives, regular web components I already touched on, But there are base classes for web components you can use. There's lit HTML. They have one called lit element, which you can extend, which handles a lot of the annoying parts of web components and makes it easier, and has templating built in. And then skate.js is an interesting one, which I had a little trouble getting to work, but I think they're kind of in between packages. But you can even use JSX with skate.js and just render that inside of a web component. So not even using React, just normal JSX. So there are a lot of alternatives out there. But in my opinion, an ideal future for this, and I don't know if the world shares this or not, but I would like to see it come to a point where you can author components in any framework. So React, Angular, Vue, Vue++, whatever, and then export it to a common runtime, so a web component or some other vanilla JavaScript, and then consume it by all the browsers because it's vanilla JavaScript. Because if you get into this scenario, you're not going to be in a point where everything's changing constantly. The authoring might change, but no one cares what language you're writing it in if in the end it does exactly the same thing. So that's my ideal future. Whether or not it's shared by others, I don't know. But here's some references. I'm going to leave this up here in case anyone wants to look at them. The next slide has the link to the slides and the demos if you want to go and look at those. So while I see some people taking pictures, any questions? I thought I saw one over there.
What is the algorithmic complexity of adding the wrapper to your?
So what's the algorithmic complexity to adding it?
Linear? Is it logarithmic?
Yeah,
Constant? Additive?
I wouldn't be able to say, I guess.
When we put things into production and we go from 10 instances up to 1 million, one is the question of, is it going to increase our workspace significantly in the browsers? And secondly, not to mention the servers,
Right.
what is it going to do to, the runtime experience
Sure.
for the consumer?
Yep. So for sure, it's going to impact your footprint on the browser, right? Because you're importing an entire new framework on top of the one you already use. So there's for sure issues there. If you're talking about scaling, that's probably a lot to do with the wrapper you're using, right? If you're using an official wrapper that the team that wrote it is familiar with, it's probably more efficient. And so hopefully it would be linear or something that is not as performance impactful. But if you're using something else that's kind of maybe off to the side, and maybe they're just doing it and it works for their 5 components on a page, I mean, you're right, there could be a lot of danger for exponential performance degradations or something like that.
If I'm running on a 1 gigabyte iPad,
Yeah.
and I've got 5 window tabs open, and they're all having to run the component. It's like adding in an extra plugin,
Yep.
and that's why Apple got rid of the plugins and Java,
Sure.
because it made a big difference in terms of their footprint
Yep.
in memory.
Yeah, there's definitely considerations there. I guess maybe I should add here for this, consider performance, memory footprint, devices that you're going to use. There are a lot of things to consider here. I definitely don't advocate you go to work tomorrow and say, David said we should do this, and then, I get in trouble, right? So it's something you should think about before you actually go ahead and do. I'm going to put this up here. Any other questions? These are the links to the demos. The demos are all on Netlify, and then the slides are there as well. Basically, this is the important one. The live demos has all the links to the slides and the code examples. Yep.
Did you enjoy doing this? That's my question. Did you enjoy trying to figure this out?
So at first, yeah, and then So I started way in advance because I thought this was going to be a big pain, and because I had done a talk at the Angular Meetup about this before, and so I had the Angular part done. I thought, okay, it's no problem. React and Vue are going to cover this. Vue was no problem. As soon as I added React and Angular, it's like they're like brothers that fight or something, and it was just a nightmare. So I think I enjoyed learning about web components. I'm not necessarily sure I enjoyed the frustrations of getting to that point. And so that's kind of why I tried to document everything here in these readmes is because there's not a lot on the web about combining some of these things. There's a lot about exporting, but not really combining. And so I'm hoping that some of these will help people out in the future so they don't go through the same frustrations. Yeah.
Have you looked at Polymer at all?
Yeah, so Polymer is a, and correct me if I'm wrong, but it's a web component library from Google, right?
Yeah, I think it's like a Google framework for making web components.
Yep.
One of your examples is Polymer. Lit HTML is a Polymer project.
Yeah, yep, it's by the same people. Interestingly, when I started tweeting about this stuff, they started liking the tweets and stuff, and so that's how I paid attention to, that's how I found out about lit element and lit HTML. But I have never used Polymer, but it's definitely, you know, alternative out there. There's the lit element I was talking about, lit HTML. A lot of people do use these, and they're fine. It's just normal web components. It's no framework, or it's minimal framework. Yep.
Yeah, I mean, to me, one of the promises of web components is that they're self-encapsulated
Yep.
and reusable. Like in an ideal world, you don't need a framework that
Right.
goes along with it. This package, which I actually also have used, fulfills that. Another framework that I have used, Stencil.js,
Yep.
is another one that also compiles to web components. And I think like lit HTML doesn't send anything else. It just has the web component.
Sure.
So ideally, your framework should export what you created at the very beginning, which is the raw JavaScript version
Right.
of it. And I think for the promise would be that if you had a large application that had a lot of reuse, you know, you had a menu that was repeated across every page in your application, you only wanted to import it once, you could import it as a web component.
Right.
And then, you know, you wouldn't have to package it along with the downloadable for each page or each view.
Right.
Yep.
Yep.
I agree that, I think at least to me, what it means is we almost, if Vue and Angular and React are really intended for projects, right? I think the idea behind them is you download React, and relative to your giant application, React is actually a tiny piece.
Yes.
So you don't mind sending it along on the front end with your application. What we need is we need more frameworks like lit HTML,
Yes.
like Stencil, that will generate these promising web components. And I feel like we're kind of not there yet. We don't have those frameworks in place.
Yeah, I agree. I feel like Angular and Vue are closest in terms of syntax because they follow the same syntax as a web component would follow. React, I think, is doing something different, which is not bad. It's just, it's a different view of doing things. It's not template-based. But I guess the way I agree with what you said, what I would alter this is saying author components in any framework, but when you export it, like you said, it's vanilla. I don't want any framework runtime with that. And maybe wrapped around this, I could have a framework for like routing and state management and that kind of thing. But really, basic UI elements for stuff like a header and that kind of thing, you shouldn't need a massive framework to do that. So, ideal world, whether or not we're going to get that way, I don't know.
You mentioned that there are polyfills out there for IE11 and stuff. Do you have any experience with how well that actually works?
Yeah, so npm.js, what's it called? Web component JS, something like that. Web component JS. Am I spelling it wrong over and over again? Web JS. Components. All right, well, there's one out there. There it is. Okay. You can all watch me misspell and mess it up. All right, so I think this is sort of the main one. It's a group of polyfills, so a suite of polyfills. Depending on what you're targeting, you may only need part of it. And even modern browsers need some of these polyfills. Except for Chrome, I guess. It really kind of implements everything, but Firefox still needs some of these.
What is your view on web components in this ideal future for smart components, or components that require state management NGRX or other state management platform?
Yeah, so question is, how would state management sort of fit into web components
Or
world?
how can you make web components fit in when you have a lot of smart components by
Sure.
nature of the product as well?
Yeah, so state management like RxJS or Redux are interesting because they kind of skip the whole data in, objects out thing. It's kind of just like, hey, inject this data anywhere you want, and then I'm going to go grab it from the central source. So I guess I'm not sure how well that would fit together. I hadn't thought about that before. But that's a good point. If you're going to use web components and you're trying to get at state from state management tool, how are you going to get at that from inside the web component? It'd be a good experiment to try out. I don't have a good answer for it, though. Good question. Any other questions? All right, cool. Well, thank you. And I will post these links on the Meetup community as well. Thanks.